When we talk about renewable energy, solar, wind, geothermal power come to mind. But there's one form of sustainable energy that we seldom discuss. I'm talking about tidal energy, the power generated by harnessing tidal streams or tides. And one island near Bicol is set to become its first beneficiary. The Philippines is surrounded by water, home to one of the richest marine biodiversity sites in the world, from where our fishermen reap their bountiful harvest that feed countless families and help sustain the economy. But with today's technology, this limitless source of food and livelihood may just become one of the country's main providers of unlimited renewable power. It's called tidal energy.
We can harness energy from the oceans, and there are a lot of ways we can harness it. Via wave, via ocean thermal energy, or what we have now is what we call tidal in-stream energy conversion, or TISEC.
Thanks to the collaboration of two companies, the first ever tidal power plant in the country would soon reach our shores. So what makes tidal power reliable? One word: predictability.
The movement of the sun and the moon do not deviate. So you can predict exactly how your tides will flow and how strong they will be flowing tomorrow to the next 18 years. And that's the huge advantage over any renewable energy source.
In terms of technology, tidal energy traditionally lags behind solar power and wind energy generation. But the tide may now be turning in its favor. With recent developments in the field, sites with lower than optimum tide flow velocities can now be used to create electricity, significantly increasing potential sites. The kinetic energy of tidal streams is transformed into mechanical energy by the turbines. A generator inside each turbine would then transform the mechanical energy into electrical energy. The electricity produced would course through a submarine cable to substations on land and eventually distributed to consumers. In the proposed plant, each turbine is 15 meters long. The beneficiaries would be communities in the island of Capul, northern Samar. Capul is short for Acapulco, commemorating its importance in the Manila-Acapulco galleon trade of the 1600s. Today, Capul relies solely on diesel generators to provide electricity to 60% of the island's power needs for only 8 hours a day.
So now we know what resource we have there, and we got Sabela on board. Sabela comes in with its extensive technical expertise, and we will be deciding what kind of turbine and where exactly we will be placing it in San Bernardino.
The San Bernardino Strait is the gap that separates the Bicol landmass and the island of Samar. And if there's one place in the eastern part of the country where the tidal flow is greatest, it would be here. Unfortunately, it is also where all manner of marine life enters our waters from the Pacific Ocean. These include the biggest fish in the world, the whale shark or the butanding.
San Bernardino Strait is isang makipot siya na waterways. So dito, kung saan pumapasok din yung mga nutrients, kung saan malakas yung current, nandun din yung rich nutrients. Importante talaga na ma-map out natin kung saan doon yung critical areas, kung saan nagpapass through yung mga marine species natin like whale sharks, mga stingrays.
BFAR would closely monitor the project.
I do believe that fish right now is more expensive than gold, so to speak. Kaya ang kailangan siguro natin, thorough, a comprehensive study on the impact of this on the environment.
The technology is harmless to the marine life. So it was tested in France, which is quite a sensitive species, and from what we saw with the monitoring equipment, there is no impact on the marine fauna and flora.
The tidal power plant will be built with the latest high-technology center, which would accurately monitor relevant data from the turbines.
So, can you imagine if we can tap these resources? And considering the Philippines is an archipelago, nababalot tayo ng tubig. Definitely, development, deployment ng ocean energy technologies will be a game changer. Not only today, but definitely in the future.
Power plant analysis of tidal energy. So let's talk about tidal energy. What is tidal energy? Tidal energy is a form of power produced by the natural rise and fall of tides caused by the gravitational interaction between Earth, the Sun, and the Moon. Tidal currents with sufficient energy for harvesting occur when water passes through a constriction, causing the water to move faster. Using specially engineered generators in suitable locations, tidal energy can be converted into useful forms of power, including electricity. Other forms of energy can be also generated from the ocean, including waves, persistent ocean currents, and the differences in temperature and salinity in seawater. Types of tidal energy power plant. First is the tidal barrage. Tidal barrage is one type of tidal energy system uses a structure similar to a dam called a barrage. The barrage is installed across an inlet of an ocean bay or lagoon that forms a tidal basin. Sluice gates on the barrage control water levels and flow rates to allow the tidal basin to fill on the incoming high tides and to empty through an electricity turbine system on the outgoing tide. A two-way tidal power system generates electricity from both an incoming and outgoing tides. The second type is the tidal turbine. Tidal turbines are similar to wind turbines in that they have blades that turn a rotor to power a generator. They can be placed on the sea floor where there is strong tidal flow. Because water is about 800 times denser than air, tidal turbines have to be much steadier and heavier than wind turbines. Tidal turbines are more expensive to build than wind turbines, but can capture more energy with the same size blades. The third one is the tidal fences. A tidal fences is a type of tidal power system that has vertical axis turbines mounted in a fence or row placed on the seabed. Similar to tidal turbines, water passes through the turbines, generates electricity. Advantages and disadvantages of tidal energy power plant. Advantages. It is a renewable source of energy. Tidal energy is environmental friendly energy and doesn't produce greenhouse gases. Because 71% of Earth's surface is covered by water, it is possible to generate this energy on a large scale. Efficiency of tidal power is far greater as compared to coal, solar or wind energy. Its efficiency is around 80%. Disadvantages. Cost of construction of tidal power is high. There are very few ideal locations for construction of plant and they too are localized to coastal regions only. Intensity of sea waves is unpredictable and they can be damage to power generation units. Influences aquatic life and adversely and can disrupt migration of fish. World's biggest tidal power plant are located on Singwon Lake Tidal Power Station, South Korea, La Larance Tidal Power Plant in France, Swansea Bay Tidal Lagoon, United Kingdom, Meighen Tidal Energy Project, Scotland, and lastly Annapolis Royal Generation Station at Canada. To know more about tidal energy, let us watch and learn in this video.
Tidal power. Tidal power is a form of hydropower that converts the energy from the natural rise and fall of the tides into electricity. Tides are caused by the combined effects of gravitational forces exerted by the moon, the sun, and the rotation of the earth. Tidal plants can only be installed along coastlines. Coastlines often experience 2 high tides and 2 low tides on a daily basis. The difference in water levels must be at least 5 meters high to produce electricity. Tidal electricity can be created from several technologies, the main ones being tidal barrages, tidal fences, and tidal turbines. Tidal barrages are the most efficient tidal energy sources. A tidal barrage is a dam that utilizes the potential energy generated by the change in height between high and low tides. This energy turns a turbine or compresses air, which in turn creates electricity. Tidal fences are turbines that operate like giant turnstiles, whereas tidal turbines are similar to wind turbines, only underwater. In both cases, electricity is generated when the mechanical energy of tidal currents turns turbines connected to a generator. The generator produces electricity. Ocean currents generate relatively more energy than air currents because ocean water is 832 times more dense than air and therefore applies greater force on the turbines. Tidal power is easy to install and renewable, having no direct greenhouse gas emissions and a low environmental impact. Because the ocean's tidal patterns are well understood, tidal energy is a very predictable energy source, making it highly attractive for electrical grid management. This sets it apart from other renewables that can be more unpredictable. However, adoption of tidal technologies has been slow, and so far the amount of power generated using tidal power plants is very small. This is due largely to the very specific site requirements necessary to produce tidal electricity. Additionally, tide cycles do not always match the daily consumption patterns of electricity and therefore do not provide sufficient capacity to satisfy demand. That's tidal power.
Tidal energy global environmental impact. A tidal power scheme is a long-term source of electricity. A proposal for the Severn Barrage, if built, has been projected to save 18 million tons of coal per year of operation. This decreases the output of greenhouse gases into the atmosphere. A fossil fuel resource is likely to decline during the 21st century, as predicted by Hubble peak theory. Tidal power is one of the alternative sources of energy that will need to be developed to satisfy the human demand for energy. In a society with increasing energy demands, it is becoming more and more important to have alternative sources of power to keep up with the ever-growing energy demand. The capacity of tidal energy exceeds that of coal and oil and is renewable. The Department of Energy has shown great interest in regards to tidal power as a perfect energy source for the future. The main environmental concerns with tidal energy are from the turbine blades striking or entangling marine organisms, as higher speed flowing water increases the risk of organisms being pulled near or through these devices. The health and safety consideration. As far as tidal power is concerned, air chambers on the turbines will need to be built on the shore, which cannot only interfere with the habitat of local wildlife, but can be visually intrusive for local residents and visitors to the area. the social and ethical considerations. In order for a power plant to be built, the potential installation site must meet very specific requirements. First, they need to be located on a coastline, which limits potential station sites to coastal states. The idle power stations need to be built in places where the difference in height between high and low tide is significant enough to power turbines. Tidal energy projects are subject to permitting by the Department of Environmental Protection under the Main Waterway Development and Conservation Act. That states one-stop hydropower permitting law.
Hello, now we are going to solve some sample problem related to tidal wave energy using tidal power plant. So here's the problem. A tidal power plant of simple single basin type has a basin area of 30 million square meter. The tide has a range of 12 meter. The turbine, however, stops operating when the head on it falls below 3 meters. Calculate the energy generated in one filling or emptying process in kilowatt-hour if the turbine generator efficiency is 73%. Okay, so to better understand the situation, so I will provide a drawing. So here's the drawing. So ang tidal power plant ko no is a simple single basin type. So single is basin and has a basin area of, so ang area do ari is 30 million square meter. So taas siya, lapad ang area sa basin, which is equivalent to 5,000 football field. So gano'n siya kadako. And then the tide has a range of 12 meters. So kani R. So from the low tide, from its lowest height of the low tide to the highest tide, 12 meter ang iyang height. Then the turbine, however, stops operating when the head on it falls below 3 meters. So iabot yung 3 meters below, di na mutuyok ring turbine because of less force. So calculate the energy generated in one filling or emptying process in kilowatt-hour if the turbine generator efficiency is 73%. Okay, so here is our solution. So the energy generated in one filling process is equal to this equation. So E, which stands for the energy generated, is equal to 1/2 times ρ, which stands for the density of seawater, which is equivalent to 1,025 kilogram per cubic meter, times G, which is the gravitational acceleration, which is kabaw na tanga 9.81 meters per second squared, times area, the basin area, which is equivalent to 30 times or 30 million square meters, times the difference between the squared of the range and the squared of the minimum head for turbine operation. So the tidal range is, as mentioned to the question, 12 meters, and the minimum head for turbine operation is 3 meters. So in this problem, we are going to find the energy generated in one filling process or emptying in kilowatt-hour with the efficiency of the turbine, which is 73%. So let's proceed to the plugging in of values. So 1/2 times the ρ or the density, which is equal to 1,025 times 9.81, the gravitational acceleration, times 30 times 10 raised to the power 6 or 30 million square meter area of the basin, times 135. So how do we come up with 135? So just plug in the value of R, which is 12 squared, minus R, which is 3 squared. So 12 squared minus 3 squared is equal to 135. So you can do it in your own calculator for you to know pod. And then, after calculation, we will come up with the result of pila ni? 20,361,881 times 10 raised to the power 6 joules. So, mao na ang unit sa energy. And then, to convert the joules, the unit of joules to kilowatt hour, we are going to multiply it by its equivalent value. So, its equivalent value is 1 kilowatt per hour is equal to 1,000 times 3,600 joules. So if we are going to divide the value of 1,000, 3,600 to the result of our energy calculation, so mo ni siya ang mahitabo. So ibutang sa ubos para ma-cancel out nato ang joules and mabilin is ang kilowatt hour. So if you are going to calculate it into your calculator, this value 20,361,881 times 10 raised to the power 6 over 1,000 times 3,600. So the result will be 5,656,078 kilowatt hour or 5.656 million units. So mao na atong result. But it doesn't end there. We are going to consider the turbine, the efficiency of the turbine generator. So the theoretical available tidal energy in one filling process has to be multiplied by 73% or 0.73 to get actual energy generated by the turbine generator. Therefore, actual energy generated or E actual is given by, so we are going to multiply the efficiency times the value of our energy, theoretical energy. So 0.73 times 5,656,078 kilowatt hour, and it will result to 4,128,937 kilowatt hour or 4.129 million units. Okay, so that is the energy generated in one filling or emptying of our tidal power plant with a simple single basin type with an area of 30 million square meter. Okay, so before we end, please note this, that for the tidal energy to be able to harness, so the difference between high and low tide must be more than 5 meters. Less than 5 meters nga difference between high and low tide, dili na siya makaharness. Gamay ra iyang chances nga makaharness of tidal energy. So there are only about 40 sites on Earth with a difference of high and low tide of this magnitude suitable for harnessing of tidal energy. So tags 40 sites sa kuno 40 sites ra kuno ang sites sa kalibutan nga maka harness of tidal energy because of its requirement nga na ang high tide and low tide niya is more than 5 meters. So that's all, and that's end my presentation.